All right, we'll go ahead and get started here. Today we'll continue the topic of subsetting. And on Friday we left off. We just talked about subsetting atomic vectors, and we said you can subset them using positive integers to say you know these are the values that you want, or negative integers to say you want everything but these particular values. You can use a logical vector, and it will return the values that line up with true or false. Okay, and if you have a vector that is named, you can use character vectors. Okay, and so I'm hoping all of that is okay. We'll continue on, and we'll start off by talking about subsetting lists, and then we'll talk about subsetting matrices and data frames and stuff like that. Okay, so a list is also a one-dimensional structure, just like the atomic vector, and so subsetting it works in a similar way. The key here is that with a list, we have two subsetting operators. We've got the single square bracket, and we have the double square bracket or $sign. Okay, I guess technically that's three, but the double square bracket and the $sign work very, very similar, where and the single square bracket is different. Okay, so it says the single square bracket will always return a list, and the double square bracket lets you pull out the components of the list. So this should just say the subsetting operators, the double square and $sign, are similar to the single square bracket, except it can only return a single object, and it allows you to pull the pieces out of a list. Okay, and the $sign is basically if the list has names, you can use the $sign and the names. Okay, so here's the analogy that we can think of. Okay, so if you think of a list as a train, okay, with like train cars and maybe cargo and stuff inside each train car, think of the train, the list as a train. The double square bracket 5 will give you what's inside train car 5. Okay, it'll give you what's inside that 5th train car. Whereas X single square bracket 4:6 will give you a subset of the train, which will be train cars 4, 5, and 6. So it itself is a train. Okay, and if you did X single square bracket 5, it gives you the train car 5. Okay, so it's still a train. It's only got one train car, but it's still a train itself. It just gives you that single train car. Okay, so the single square bracket will give you the train car. If you want what's inside, you need to use the double square bracket. Is that okay? So here's just kind of a couple examples here. So here I've got a list. X is the vector 1 through 4, and Y is the vector 9 through 6. Okay, so this is, you can think of a train with train car X and a train car Y. And if I do double square bracket 1, it'll say, look at that first train car and give me what's inside. That's going to be the vector 1, 2, 3, 4. A double square bracket with the name Y will say, give me the train, what's inside train car Y. Okay. A single square bracket YX will say, give me the actual train car Y and the train car X. And so you get back a list. So it'll say, you know, give me back the list with elements Y and X, and it does that. Whereas I need to fix this. So here we have that. Referencing with single square bracket Y and X gives me back a list with two things. If I use double square bracket Y, and X, this is not going to work because you're basically asking, give me the contents, what's inside train car Y and what's inside train car X. And you're not allowed to do that, okay? Because you've got two different things and you can't just say, I want what's inside over here and what's inside over here and like somehow merge them together. Because the contents of those train cars could be different and you can't just like stick them together, okay? I mean, you might be able to using unlist, but subsetting is not the way to do that. Okay, over here, D is a list of three things, 1, 2, 3, true, true, false, and the character A. Single square bracket 1 gives you back the first train car, so it's named A, and it says 1, 2, 3. And if you ask what's the type of D, it's going to say list. What's going on? Whereas over here, when you ask for D double square bracket 1 and type of there, it just returns the vector. It tells you what's inside that first train car, which is a vector, and you know what's its type. It's a type double. Is that distinction okay? The difference between the single square bracket 1 to subset gives you back the train car itself, the list itself. Single square bracket will always give you back a list, whereas the double square bracket gives you what's inside the list, the element inside the list. Okay, and we're going to keep doing a few more examples here. So L1 is another list, a list of three things. The numbers 1 through 8, the characters A, B, C, D, and the integers 5, 4, 3, 2, 1. Okay. So if you do L1 single square bracket 1, that is a list of one element, and inside that is the vector 1 through 8. Okay. Whereas L double square bracket 1 is a vector. Okay. So this is a list, and this is the contents. This is a vector. So if you do L1 single square bracket 1 and then single square bracket 2, this thing doesn't exist. Okay, it gives you back a null list, a list of null. Okay, because you're saying basically you're asking subset the train down to the first train car and then give me the second train car, and that second train car doesn't exist, right? So you get the null. Over here it says give me what's inside the list, give me what's inside that train, which is the vector 1 through 8, and then give me subset that and give me the second element. Okay, and that will give you the number 2, because you're saying what's inside the list. Inside the list is the vector 1 through 8. You're pulling that out, and then you're saying, okay, within this vector 1 through 8, give me the second element, and so this works. Is that okay? And it's similar if you embed a list inside a list, okay? So here, I've got L2, and it's a list of three things, and the first thing in L2 is the list L1, okay? So L1 is this thing that we created earlier, okay? It's the list of three. And so the first thing is the list. Then we've got the vector 10, 20, 30, and then the letters D, E, F, G, H, okay? So, so this is what we've got. So L2 is a list of three, and inside that, first train car is a list of three, okay? So you can think of it as you've got a train, and inside the first train car is another train, okay? So you've got a train of three, and inside the first train car is another train of three, okay? And then inside the second is 10, 20, 30, and inside the third is D, E, F, G, okay? So how do we reference something here, right? So this letter B or something, or the number 2 here, where is the number 2 located? Okay, when we tell R how, instructions to get number 2, we have to say, look inside the first train car then inside that first train car, you'll find another train. And look inside the first train car of that smaller train, and then give me the second element there, okay? If you don't give it that instructions and say, look inside the train car and then look inside the train car, it's not gonna work, right? That's the only way we can get to elements like 2 or the letter B or something like that, okay? Otherwise, it'll just pull out the thing. So if we say look inside, L2 single square bracket 1 is not a look inside. That just says give me back the contents of the, or not the contents, give me back the first train car, okay? Which is going to be a train car, and inside that is a train of 3. So it's a list of a list, okay? So L2 is a list, and inside that is a list, okay? So this, when we ask for the structure, we see it's a list inside a list of 1, and in its contents is a list of 3. Okay. If you do this double square bracket, then that says look inside, right? So here you say look inside train car 1, give me the first thing that you see. That's going to be, so again, we've got the train, we go inside, and then there's a smaller train, and we're saying look at the first car in that smaller train. And so that itself is a list, okay? And if we try to say give me the second thing, it gives back null, because here this operator still gives back a list. If we want the element 2, we have to say look inside the list and look inside that list, and then give me back the second element. Okay? And when you get to the point where you understand the difference between this and how to properly reference things within nested lists, then you understand list subsetting, okay? And I know it's weird because it's like lists inside lists, train cars inside train, other trains, and things like that. And it feels weird, but we have to come to a point where we are comfortable with the difference between the double square bracket and single square bracket, because it's very important in R when we're working with lists, which is quite often, okay? And if it feels confusing the first time you see it, or this is still fairly new to you, it's okay. I understand it can be weird. So review these notes and just kind of play around, and you can kind of create this structure and give yourself little challenges and say, well, how do I reference the letter D? Okay, what do I need to do? And things like that. Is that okay on subsetting lists? Okay, all right. Let's talk about subsetting matrices and arrays, okay? So remember that a matrix or an array, these are just atomic vectors with what? With dimensions, right? All we've done is we've taken an atomic vector and we've attached dimensions, right? If we get rid of the dimensions on a matrix, it turns back into an atomic vector. Or if you take an atomic vector and you add dimensions, it turns into a matrix or an array. And there's a few ways to subset this, and probably the most common is you're going to subset the matrix using multiple vectors, okay? But you can also subset it using a single vector, and you can also subset a matrix using another matrix, okay? I'd say this is probably the least common way, but it's still useful, and we'll look at each one. Okay, so I think we gotta figure out how to draw all these things out. Okay, so here is a matrix A, and it's just got the numbers 1 through 9. And so, and then I've named the columns A, B, and C. Okay, so if I do, if I ask for what is A subset 1:2, comma nothing, it's going to say give me back the first and second rows, and the comma nothing says all the columns. Okay, so I get rows 1 and 2 and all the columns of rows 1 and 2. If I say true, false, true, BA, comma, BA, this is going to give me back the first row and the third row, because those are the rows that correspond to true, and then it returns back the columns named B and A in that order, and so we get this. And over here, 0, -2 says give me back none of the rows, 0 of the rows, and give me back the all the columns but the second column. Okay, and so you can. So this is subsetting using multiple vectors. Okay. And I think we're probably familiar with kind of this method of subsetting matrices. One thing to note is that when we do subsetting with the single square bracket, R will simplify the results to the lowest possible dimensionality. So for example, if I ask, is A a vector, it's going to say no, right? A is this matrix 3 by 3, and it's not a vector. But if I subset and I just say, I want the first row of A, it's going to simplify it down to a vector, atomic vector with elements 1, 4, 7. Okay, and if you ask, is that a vector, then that's true. So this has no dimensions. Okay, it looks like it's 1 by 3, but it's not. It's an atomic vector with 3 elements in it. This is not. There's no dimensions associated with this. Is that okay? All right, so here I'm creating a matrix. Now we'll subset a matrix with a single vector without a comma. So here I've got the matrix of the letters A through Y, the first 25 letters, and they're just kind of arranged in this way, 5 by 5. Okay? And so here I can say, give me back. I give it a single vector, a vector of 8 and 9, and it's going to just select the 8th and 9th values in this matrix as if we just treated this not as a matrix of that's 5 by 5, but as an atomic vector of 25 elements. Okay, so if we treat this matrix as a vector of 25 elements, you know, R fills out the matrices down the columns, okay, and it's going to go like this, and it's going to say pull out the 5th and the 9th elements, and it's going to pull out HI. Right. And so it says hi. Okay. Is that all right? So that's just you can treat the matrix as if it were a single vector, and you can subset it using a single vector as well. Okay. The matrix has 2 dimensions, and so the last way you can subset the matrix is by giving it a list of coordinates. Okay, so you can think of this as, here I've got a matrix, 5 rows and 5 columns, and I want basically the element at row 1, column 5. Okay, so we're giving it a list of coordinates, or a matrix of coordinates. So we go row 1, column 5, that's U. Okay, row 3, column 1 is going to be the letter C, and so on and so forth. Row 2, column 3, we'll pull out the letter L. Okay, and so here, because we've got a matrix which we can treat as kind of this grid object, we can say I want the element at this coordinate and this coordinate and this coordinate, and so you are subsetting the matrix using a matrix of 2 columns. A column for the row coordinate and a column for the column coordinate. All right, and so here, using that, we can pull out UCLA, and that's I don't know if it's useful, but it's a way to subset a matrix with another matrix. Does that kind of make sense? And so if we have a 3-dimensional array, okay, with rows, columns, and sheets or layers, we can subset an array using this method with a matrix of 3 columns. Okay, 1 column for the row coordinate, 1 column for the column coordinate, and 1 column for the kind of sheet coordinate there, okay? So here I've created, gets cut off there. Okay, so here I've got this array with the elements 1 through 12, and they are in 2 rows, 3 columns, and 2 sheets, okay? And so this says, give me back the element in row 1, column, row 1, column 2, first sheet. Row 1, column 2, first sheet is 3. This says, give me back the element in the second row, third column, second sheet. Second row, third column, second sheet gives me back 12. And so when we use this matrix to subset the array, it gives me back the elements 3 and 12. And so in higher dimensions, you can do the same thing. You just need to have all the coordinates. And it seems kind of complicated, but I guess it could be helpful depending on your situation. All right, we can subset data frames, okay? And so if we remember, data frames are built on top of lists, right? But they're arranged in this rectangular table format. So a data frame can be subset the way you subset a list. It can also be subset kind of like the way you subset a matrix, okay? Because they contain kind of both. They behave similarly, okay? So here I've created a data frame with column X, which has the numbers 1 through 4, column Y, which goes 4, 3, 2, 1, and Z with the letters A, B, C, D. And this is what the data frame D looks like. And here it says subset data frame subset the data frame, and this is using the matrix notation, using a logical vector to specify which rows we want. Okay, so here the logical vector is the rows where y is even, right? df $y % mod 2 is equal to 0. So it's basically give me the rows where y is even. So it's going to give me true for the first row, false for the second, true for the third row, and false for the fourth row. Okay, and so it returns back the rows where this statement is true, and it returns back rows 1 and 3 where y is even. And that's what we have here. Okay, and because I have comma nothing, it's going to give me back all the columns as well. So it gives me back columns X, Y, and Z of the data frame. And so this is very useful, and you can say something like, you know, I want all the rows where state is equal to California, or something like that, right? I want all the rows where something. We've got a question back there. Percent is the modulo operator. So it's kind of like, it's the remainder. So if you did 12 mod 5, okay, 12 divided by 5 is 2. Maybe that's not the best one. Okay, we'll do 17 mod 5, okay? 17 mod 5 will be 2, okay? Because 17 divided by 5 will be 3 remainder 2. If you don't do it fraction, but if you go back to, I don't know, when did you learn division with remainders? 4th grade, 3rd grade, something like that, right? So 17 divided by 5 would be 3 remainder 2. And so 17 mod 5 will be 2. So if I did 17 mod 5, this gives me 2. I think. And then 17% / %5 is the integer portion of integer division. Okay. Okay, but basically the modulo is it divisible by this number evenly? Well, modulo equal to 0, right? So, but you can do like handy little tricks. Like I don't know, like let's say you need, you're going to form groups of 6, okay? You're going to form groups of 6 and you have a list of, I don't know, 600, let's say 100 students or something. And then you just want to go down the list and you want, you know, the first person will be the leader of group 1 and the 7th person will be the leader of group 2 and what is the next person? The next person, right? So how do we do that? We would just do like 1 through 100 and then %% equal to 1, right? And so this will, I have to subset this. 1 through 100 where this is true. Okay. Why didn't that work? And because I did this. Okay. So then this will be, I don't know, the first person, 7th person, 13th person, these are the people who start off the next groups and stuff like that. Okay, but anyway, that's the modulo operator. Okay, and then so with the data frame, going back to subsetting, okay, so you can say I want the rows where it's divisible by 2. You can also say, you know, I just want the first and third rows, okay? And that works just fine. And here, I'm saying I just want, so here I want the first and third rows and I need to put in a comma there, okay? If, and over here, I just say I want the columns X and Z, and there's no comma before or after it. And so here it's like I'm subsetting with a list, okay? Because the data frame is a list structure and it's basically saying I want the list elements named X and Z. Okay. However, I can also do basically the same thing and use the column and say, and we're going to get the exact same result here, where here I've said I want the data frame, I want all the rows and the columns X and Z. Is that okay? I want the columns named X and Z, and over here I want the list elements X and Z. Perhaps, let me just rearrange a few things. I'm going to put that there, and we'll go back and just illustrate the difference between these things. Okay, so over here, putting in the comma will return rows 1 and 3. If I leave off the comma, then it returns columns 1 and 3. Okay, and so when you're specifying the columns by name and stuff, this is fine. Okay, including or omitting the comma doesn't make a difference here. I'll say it doesn't make a difference. Whereas including or omitting the comma does make a difference. Okay? So the way we subset data frames, whether we include or do not include the comma will depend differently, right? Including the comma, we'll say, we'll treat it like a matrix and we'll say I want these rows or I want these columns. When you don't include the comma, it treats it like a list and it's going to give you back, you know, the first and third, I'll say it, elements of the list. All right, there's an important difference if you select a single column, okay, when using the single square bracket. when you subset the data frame with a single square bracket like this in X, it will preserve the data frame nature. It will keep it as a data frame. Whereas if I use the matrix form and do comma X, this pulls out the X column and it becomes a vector. And if I use data frame $X, this also becomes a vector. Okay. And what would happen if I did df double bracket X? Does that become a vector, or does that remain a data frame? This becomes a vector. Okay, because $X and double bracket X is pretty much the same. Okay, so when so this will remain a data frame, but this becomes a vector, and then these become vectors. Is that okay? All right. What would happen if I tried to do this? Or is something wrong? Will this work? Will this pull out the rows where cylinder is equal to 4? Yeah. Yeah, we need equals equals, okay? So need the double equals for the logical test to pull out the rows that have cylinder equal to 4. All right, what will happen here if I have negative 1:4? This will complain that I'm mixing negative and positive integers, because negative 1:4 is actually negative 1, 0, 1, 2, 3, 4. And if I want to get rid of rows 1 through 4, I need to put that in parentheses. Okay, and this will you can't mix negative with positive, and so over here this will omit the first 4 rows. What will happen if I do empty cars $cylinder less than or equal to 5? Yeah. I need a comma, right? And so if I include the comma, it will specify the rows where this statement is true. If I omit the comma, then what's basically happening is I've got a true-false vector, and now I'm trying to subset empty cars using a true-false vector. And so if I say empty cars and we try to use this, it's going to say you're trying to select like column 26, which is true, and there's no column 26 in empty cars, right? Because it's using a true-false vector, and so it's looking at it as a list, and it's saying you're asking for the 26th element of this list, and that doesn't exist. Okay, and so that's why it says undefined columns are selected. Similarly, if you have an OR operator or something like that, you need to make sure you're using the OR operator on two logical vectors. Here I have a logical vector over here, and then just an integer over here, and so that it gets confusing. It gets confused. So, for example, if I did empty car cylinders equal to 4, this will be a true-false vector. But if I do OR 6, what does this become? This is going to become true for everything, right? Because it's going to coerce the 6 into true, and then it recycles the true, And then so you've got a true false vector over here, and then another vector of trues over here, and it's going to say this or this, and everything becomes true. So if you want it to be an actual true-false thing, okay, then you need to have two logical vectors. This will coerce the 6 into a true, and then the combination will be true for everybody. So that's not going to work. Okay, if I did empty cars 1:20, what's going to happen here? This is going to pull out, it's going to ask for the first 20 columns, the first 20 elements in the list, because it has no comma there. And so it's going to cause a problem. So you need to specify the column to say, I want the first 20 rows. All right, is that okay? All of this subsetting of data frame stuff. Simplifying versus preserving. We have this option called drop equals false, which will preserve the nature of the thing that we're looking at. So here's a table, but I would say the important distinctions are in this thing where we're looking at an array, okay? So when you subset a matrix and you ask for just like one row out of the matrix, it's going to not return a matrix of one row and 5 columns or whatever. It's going to just return a single vector. It simplifies from the matrix down to an atomic vector, okay? If you want to keep the matrix in the matrix form, so you've got a 5 by 5 matrix and you want just the first row of the matrix and you want to preserve it as a matrix of one row and 5 columns, you can use the option drop equals false. Okay, so x1 comma will return the first row and simplify it down to an atomic vector. x1 comma, so first row, blank for the columns, all the columns, comma, drop equals false will preserve the matrix structure. Okay, same thing over here, and people get weirded out because when you're subsetting a matrix, they're used to seeing only one comma there, right? I want these rows, I want these columns, and you have one comma. But you can have 2 commas, okay? First, you specify the rows, specify the columns, and then you specify drop equals false, and that will preserve the matrix structure, okay? Along with data frames, if you pull out just one of the columns, it will simplify it. But if you want to preserve it as a data frame, you can use drop equals false, okay? Or you can use double brackets, okay? X double bracket 1 will simplify. We'll just simplify the column into an atomic vector. If you use single square brackets, in the way we subset a list, it's going to preserve the data frame nature, the list nature of the structure there, okay? I didn't show data frame where you specify one row, because if you specify one row in a data frame, it will never simplify it, okay? It will always preserve it as a data frame structure, because the data frame, you're basically pulling the first element out of all the different columns, and so that's going to preserve the data frame structure there, okay? And you can do it for vectors, lists, and factors. I would say these are less important to worry about, okay? So with, if you do double square bracket on a vector, it just gets rid of the names, where single square bracket will preserve the names. With a list, single square bracket will keep it as a list, where double square bracket pulls out the contents of the list. With factors, it will preserve all the levels, and if you do drop equals true on the factors, then it gets rid of levels that aren't used. Okay, but here's the important one, okay? So here I've got a matrix A, and it's the elements 1, 2, 3, 4. 1, 2, 3, 4, okay? And it's in 2 rows, 2 columns. So here if I say I want the first row, all the columns, and don't simplify the structure, then it returns a matrix with 1 row and 2 columns. Okay, so we can see that this is a matrix. Whereas over here, if I just say, give me back the first row, it says, oh, I've simplified it for you. It's now a vector. Okay. And so this might be important if you're trying to do some like matrix multiplication, and you need to preserve the dimensions, some of the column dimensions of the matrix. Okay, because in matrix multiplication, the dimension matchup is important. You need to have, the number of columns in this matrix needs to match the number of rows in this matrix that you're multiplying with. Okay, similar for data frames. If you use single square bracket, it will keep it as a data frame. If you use double square bracket, just like with a list, it's going to just extract the contents and give you back the vector. Okay. With data frames, yeah, you can also do drop as false and things like that. The $sign operator works. Sometimes students will want to pull out a column in a data frame, but they want to keep that column as a variable. Okay, and it's possible. It's possible. You can say, I want to pull out, the column cylinder, and we're going to not explicitly type out the word cylinder. We're going to just keep it stored in the variable name. And so if you say empty cars $sign variable, this isn't going to work because it's going to say I have no column named variable. But if you use empty cars double bracket var, it's going to say, well, what is var? Var is cylinder. Okay, we're going to pull out the column named cylinder, and that works. Okay. $sign will do partial matching. If so, here the name is ABC, and you can just match it with the lowercase a there. Okay, I know I've got a few more minutes here. Okay, so hang on. Out of bound indices. Okay, this is not something we do on purpose, but this is something that we will do on accident, and we've got to be aware of what happens here. Okay, generally. So if you specify an out of bounds index for a vector, atomic vector, it's going to return NA. So what that means is X is a vector with the elements 1, 2, 3, 4. There's only 4 elements in X. And you can ask, what's the first element of X? And it's going to say 1. What's the fourth element of X? It's going to be 4. But if you give it something that's out of bounds, and you say, what's the fifth element in X? It doesn't give you an error or a null. It gives you a missing value. Okay, it says, that value, I don't know what the fifth element of X is. Okay, it's missing. Okay, and if you say, and if you give it a missing value, right? If you say, give me the what is the element at this missing location, it's going to give back NA, right? And if you try to subset using null, it's going to give you back a 0 length vector there, okay? Here's kind of a table of what happens. Out of bounds on an atomic vector will give you a missing thing, all right? Whereas if you do a single square bracket out of bounds thing on a list, it will give you back a list of null. Okay, so this is basically saying I've got a train of 4 things, 4 train cars, and I can ask what is in the 5th train car, or not what's in, what is the 5th train car? Okay, that's a single square bracket with an out of bounds. Okay, what's the 5th train car? There's only 4 train cars. What's the 5th train car? It's going to say it's a null train. Okay, list null is what it gets. On the other hand, if you use double square bracket on an out of bounds, it's going to give you back an error. Okay, double square bracket again says what's inside the train. Okay, what's inside the train car? So double square bracket 4 says what's inside the 4th train car. If you say what's inside the 5th train car, which doesn't exist, that gives you an error. It's going to say out of bounds subscript. It's going to say list error out of bounds subscript. Okay. And so these are some of the distinctions. Generally, we run into out of bound problems when we're like making loops and we have our beginning and our ends specified poorly, right? So you might say like, do it for I and 1 through 10, but maybe the thing you're dealing with only has 8 elements or something. So then when it gets to I is 9 and I is 10, you're going to often run into these out of bound problems. And this is where you're going to get these kinds of errors and stuff. Okay, there's a few things. You can mix up subsetting along with assignment, and I think these slides are straightforward enough for you to kind of go through and learn and cover some of these things. There's a few things I want to just highlight here, okay? As far as important applications of subsetting, maybe I'll go through into the notes and I'll say star. These ones are important. These ones are less important. Okay. You can do ordering, okay, with subsetting, subsetting using ordering, and I'd say that's pretty important. And then this is going to be important. You can remove columns from a data frame by just throwing null into the column. Okay, so here I've got a data frame with XYZ columns, and you can just erase an entire column by saying null to the list element. Okay, and then of course we've seen this already, but this is very important in selecting rows based on a condition here. Okay, and the other ones are useful and handy, and I'd say suggest you to review the notes. I don't think we've got time. I don't want to spend a whole lot more time on subsetting or anything on Wednesday. On Wednesday, we'll keep moving on in terms of topics. And so I'll just add a few corrections and revisions to the notes and post them online. Okay, we'll end there, and we'll see you guys on Wednesday.